How you doing? Okay, this video is going to be based around another video based around mapping and charts. This here in front of me, or in front of us, I should say, is a nautical chart. It's from it's Lake Erie from the United States, NOAA. It's obviously Lake Erie is one of the Great Lakes. I could have picked one of the bigger. I could have picked one of the bigger lakes, like the one that I can't remember the name of it, the one that Chicago is on, and Milwaukee and that. But this is just fine. So this is a pretty detailed map, right, or chart, I should say, as you can see. And as you can see, it's using a grid reference, right? And there is scale here. There is from here. There's in 3 places on the map, but from here to here is 40 nautical miles, and there's another 10 nautical miles in segments here for if you want to use your compass to show smaller segments of distance. So you may not want 10 nautical miles or 20 nautical miles. You might want only like 4 or 6 or whatever it is, right? But this whole line here, from here to here, is representing 50 nautical miles. 50 nautical miles in statute, because I'm going to be using statute, is 57.454 statute miles. Exactly. Okay. Now, as you can see, it's all in a straight line because nautical miles are straight. That's the whole purpose of them. That's why they were using celestial navigation. That's how they're used, is they're a straight line. Because it doesn't matter. I'm just going to throw something in here. It doesn't matter if you want to claim, right, stupidly, right, and ignorantly, that you're calculating a distance along a tangent, right, which is a straight line, right. It just won't be in tangent, just won't be in the orientation of horizontal. Still be a straight line. It doesn't matter if you want to say that you're calculating a distance along the tangent. That distance you're calculating is a nautical mile distance, right? So even within that paradigm, the distance you're calculating is a straight line distance. Now, in reality, all nautical miles, because they're miles, are straight lines, right? They're the same as a statute mile. They're just a little bit longer. Now, as I said, I've brought up before that I don't know for certain whether the ratio between nautical and statute miles is correct, and there's some evidence that it's not, but I'm not going to go into that for right now, because a nautical mile will still be a nautical mile. The only difference is that how many statute miles or what ratio to statute miles it is, right? But a nautical mile will still be a nautical mile. That won't change, right? Because it comes from minutes of degree. So, so you can't change the size of minutes of degree. They are what they are. So to get to where I'm going with this, I'll come back to this chart in a few minutes. Let's go to a different map. So this is a less detailed map, but it's easier to see, right? And I just want to show. Just go to here. So I have 3 distances, right, across Lake Erie, and I'm using travel math. Now it doesn't matter which one you use; they all try to use the same thing. They claim they use they're calculating distance here using the Vincenti algorithm and the WGS84 ellipsoid model of Earth. It's not a model, it's a datum, and basically they're trying to claim that they're using an arced distance, right? So what they're trying to claim is from Detroit to Sandusky. Or from Detroit, Michigan to Sandusky, Ohio, there's 63 miles of an arc. Well, we know that miles are straight, right? We know that. Now, you can arc them, but the mile itself is a straight line. And distances are straight lines. They're not arcs, right? There's many reasons for that, right? But we'll just take what they're showing here for the moment, right? So from Detroit to Sandusky is 63 miles. We all know Sandusky, it's where NASA have their 200-foot high vacuum chamber. Then from Detroit to Buffalo, it's 216 miles, right? So Detroit to Buffalo, 216. And then from Buffalo to Sandusky is 220 miles. So altogether, right, if we make a triangle out of them, right, we have a 220 mile side, a 260 mile side, and a 63 mile side. So we're making a triangle out of three distances given to us by a site that are claiming to use the Vincenti formula, right, for the distance. Now, I could spend a month talking about the nonsense that they have to do with that and the Haversine formula, and how they have to start off with flat. But I'm not going to go into that now, because it's not important right now to what I'm going to try and point out, right? So, as you can see, I'm just going to move in a little bit on this page, right? So you can see it clearer. The perimeter is the area is 6,781.22422. The perimeter is 499, right? So that is the full perimeter is 499 miles around the edges or sides of the triangle here. So if we just come back to here, and I'm just going to I'm just going to make a little triangle on this. Where are we here? Oh, sorry, I need to go there. Tools, annotate, line. Okay, so I'm going to change the color if I need to. So Detroit here to Sandusky, right? I might change the color to something a bit brighter. Maybe red is better. And from Detroit to Buffalo, New York, and then from Sandusky up to Buffalo. Well, it's not up because that would be north or whatever. But here you have the full. Here is the full triangle. So that's 499 miles right there. Now, they cannot be curved distances, right? Not only are they shown in miles, right, but they can't be arc lengths. And the reason they can't be arc lengths is if all these three are arc lengths, then you should be able to take this as is, let's just say, right? Let's just say you did it. I didn't do it on this chart because it's so detailed. I wanted to have just one point, a couple of just simple points, and a colourful map to show it on. But you should be able to take this then and place it straight onto a globe art, and these three red lines not increase in length, and the area within them not increase. But that's impossible. It's impossible to take this and place it onto the surface of a globe art, and those three lines not increase in length, and the area within those three lines not also increase. That's impossible. It's geometrically impossible. What's also impossible is to take three arc lengths like that and turn them into two dimensions and keep the lengths the same. The point being is that Detroit cannot be 63 miles away from Sandusky and that length be arced. That cannot happen, right? And the same for Sandusky to Buffalo and Buffalo to Detroit. The reason you can't is because as soon as you do that, right, as soon as you try to say that they're an arc length, what happens is you cannot then place them onto a map. Right? You might hear one of my cats here moving around. You cannot then place them onto a map. It is impossible to go from three-dimensional to two-dimensional. You cannot do that. So you cannot claim that these are arc different distances, like I was shown with that Q math here, or not travel math, right? Whatever they say here, no matter what they're trying to claim, any of these type of sites, it's always a straight line distance. It has to be, because you cannot transform from three-dimensional to two-dimensional, because these can't be three-dimensional distances, right? It can't be arc lengths, I should say, on a globe, and that area in there, right, be what's between those three arc lengths, and then you place that onto a map. That is impossible. It cannot be done. You cannot take two dimensions and turn it into three dimensions, and you cannot take three dimensions and turn it back into two dimensions. In this, right, that can't be done, right? So there's no way for this to be one of those oxymoron, right, spherical triangles. It's impossible, right? Because you would not be able to put it onto a map, because a spherical triangle is three-dimensional, right? It will not go, as I've shown in previous videos, it'll only go onto a three-dimensional spherical surface, because spherical surface is three-dimensional, as I've proven in the past. And one of the ways I did it was with the spherical triangle, oxymoron. But point being is, these cannot be the lengths along the arcs of a spherical triangle, because you could not place that onto a two-dimensional map. You wouldn't be able to do it. Because even if you did try to do it, you'd have to have all kinds of there'd have to be all kinds of equations and that to let people know that there's a whole area in here, or something that has been taken away, or something. The whole thing just doesn't work. It cannot work. It's just geometrically impossible. So if you want to believe that the Earth is a globe, I don't have any belief about the Earth being flat. I know it is. Here's proof as it is. If you want to be a believer in something as stupid as a globe Earth, then you're welcome to do that, right? But you cannot claim that there's any measurements of a globe Earth, because there isn't, and you cannot claim that this triangle here, right, is these three lengths are arc lengths. You can't do that, because those three arc lengths cannot be placed onto a flat map without their distances being changed. So you would not be able to take, let's just say, these three lengths off a globe and then place them onto a two-dimensional map without all three lines shortening, right, and the area within them shortening, right. Now that would mean that if you did that, you would have to have, especially on like maps like this. I know it's not a map; it's more of a nautical chart, but obviously it has some surroundings, obviously Detroit and all these, Cleveland and all that. But you would not be able to see, if you can see here, see the way there's a grid pattern here as well. All that is, and the grid here, all that is impossible. All of that is impossible. None of this can be on a three-dimensional surface and then placed onto a map. Because within here, there would have to be, right, there would have to be particular equations there to help you determine any distance between any of these points. Let's just say you used your navigation compass, right, for distance as they use, and you went and you took this 30 nautical miles here, and you went between 2 points over here, or between this point here and this point here. You would then need, right, you wouldn't be able to just use that, because see that 30 nautical miles there with your compass? You wouldn't be able to use that here without an extra equation, whatever, or formula to change this length here into what it really is on a globe. You couldn't do it, right? You could do it, but you'd have to have those equations. They'd have to exist in reality. They don't. I can take, or a navigator, or anyone can take a navigation compass, can't remember the proper name of them, I just use the navigation compass, as you use them for distance, right? And you think between these 2 points here, which is 30 nautical miles, and you can know for certain that when you keep a compass even and you bring it to any 2 points between here or anywhere on this chart, that you know that is 30 nautical miles. You don't have to add any other equation. There's no formula needed with that to know that that's 30 nautical miles. All you'd have to do is, if you want, is convert it to statute. Or kilometers or whatever, which is all just straight to straight. There is no equations, there is no formulas on this chart here, or any chart, or any map anywhere, for the conversion from two-dimensional to three-dimensional. It just doesn't exist. So when we have a triangle made between these 3 points, and there is, as I showed earlier, the area was 6,000. 781.22422. That would be the full area within this. So that's the full area within that, right? The perimeter is 499, and the full area is 600. 6,781.22422. I knew it was right the first place. That's whatever way I'm looking at. So you will know that you have that as an area within this. The full area within that is 6,781.22422. Right? That is a definite. That there's no way, no need to increase that. Right? There might be some small differentials, right? And the reason there might be some small differentials, I'll just point out now, is that where I have that here, these distances might be between airports. So the airport might be slightly out here for Detroit, and for Buffalo it might be slightly north, and for Sandusky it might be slightly south. But there might be some very small variations. But if you wanted to get really technical about it, but other than that, there'd be no difference. The amount of area, the 6,000 whatever area is that is the area. That's the area that's within this triangle. And what is it encompassing? Right? What is most of this area made up of? Right? Water. Most of it is made up of water. So part of the area is, the main part of the area is made up of water. So no matter what way you twist or turn it, you will never be able to make this work on a globe. These distances, this map, right? This map, this chart, any of this can only work if the earth is flat. It is the only way geometrically it can work. Now, you can believe all kinds of nonsense if you want. That's up to you. But I know, and I can tell you, that anyone who's honest with themselves can know for definite that this proves the earth is flat. That's another thing that proves it. Everything seems to prove it. Because it is flat. There's no way around it. So there is just there's no way to avoid this. Like, you can't add in extra water to this and there. You can't add in extra area to this and there. You can't add in extra land to this and there. You just can't do it. This, like, look, most of Lake Erie, or half of Lake Erie anyway, is within the triangle. That means water is within the triangle. That means water is lying flat, because it has to. Because it does. But you see the point I'm making? This can only happen if the earth is flat. There's just no way to go from 3 dimensions back to 2 dimensions, and the 2 dimensions back to 3 dimensions, without all those equations and formulas that don't exist, that nobody used ever in the history of maps and navigation. Nobody ever needed to use them. They've moved around time zones, they've messed around with other things, but there's certain things they just can't mess around with. And you cannot mess around with straight line distances, and you cannot mess around with area. It's all 2-dimensional. It cannot be 2-dimensional on a map and then just be the same distance as an area on a globe or on a sphere. It can't. These things are geometrically impossible. There's no way around this. So that's all I want to point out about this. I might do other videos on this topic, but right now that's all I want to point out. Thanks for watching.